You ever just flip a light switch and not really think about it? Of course, we all do it. But in that single instant, you're tapping into this huge, invisible network of power. Today, we're going to pull back that curtain and see exactly how it all works.
No, really think about it for a sec. What is that invisible force that just floods your room with light or charges up your phone? It's definitely not magic, but honestly, it's just as amazing.
You know, that simple flick of the wrist? It's actually the grand finale of an incredible journey, one that starts hundreds, maybe even thousands of miles away, and ends right there, inside that little glass bulb. So let's follow that path, right from the power plant all the way to your wall outlet.
All right, so how on earth does electricity get from a massive power plant way out in the middle of nowhere to that utility pole right on your street? Well, it's a story of some serious power and some really clever engineering.
Okay, so it all starts at the power plant, where electricity is generated at about 11,000 volts. But to push that power across the country without losing a bunch of it, they have to step it up, way up, to a mind-boggling 132,000 volts. It's kind of like cranking the pressure on a fire hose way up so the water can travel for miles. Then, as it gets closer to your town, substations step it back down for local travel until one last transformer, probably on a pole on your street, brings it down to the safe, usable 220 volts your house needs.
So the power has made it all the way to your neighborhood. Now for that final jump. How does it get from the pole into your living room? It all comes down to three very important wires.
It's a pretty elegant system, actually. First, you've got the live wire. That's the hot one, carrying the 220 volts of power. Then, there's the neutral wire. Its job is to complete the circuit, giving the electricity a path to return to the source. And finally, and this one's a big deal for your safety, you have the earth wire. Think of this one as your personal bodyguard, ready to divert any dangerous electricity safely into the ground if something goes wrong. And you can see here, those three wires make their way from the pole directly to your home's main distribution board or panel. This thing is basically the nerve center, the mission control for your entire home's electrical system. From here, power branches out to every single room. All right, so once the power's inside your walls, it's sent all over the place through a network of circuits. And the way these circuits are designed is absolutely crucial, not just for convenience, but, you guessed it, for safety.
So here's a good question. You know how with some old, cheap Christmas lights, if one bulb goes out, the whole string dies? Why doesn't your house do that? So here's a good question. You know how with some old, cheap Christmas lights, if one bulb goes out, the whole string dies? Why doesn't your house do that? It's a really good question, and there's a very smart reason. The answer is all in the wiring. Take a look. On the left, you've got a series circuit. Everything's on one single path, so if one bulb breaks, the whole path is broken, and the party's over. But look at the one on the right. That's a parallel circuit. See how each bulb has its own personal uninterrupted lane back to the power source? And that, right there, is the secret. Your home is wired in parallel. That's why your toaster doesn't have to be on for your TV to work, and it's why one burnt-out light bulb in the kitchen doesn't plunge your entire house into darkness. It's a simple, brilliant design choice that makes modern life possible. Now, let's talk about the unsung heroes of your electrical system, safety devices. The old-school hero is the fuse. You can think of it as a tiny, self-sacrificing bodyguard for your electronics. Inside is a little wire that's designed to be the weakest link. If there's a power surge and way too much current starts flowing, that little wire takes one for the team, it melts, breaks the circuit, and saves your expensive TV from getting totally fried. But, of course, technology has moved on. While older homes had these porcelain fuses you had to replace, most of us now have these things, miniature circuit breakers, or MCBs. Instead of a wire melting, an MCB just flips a tiny switch inside when it detects an overload. The best part? No more fumbling around in the dark with a flashlight trying to find a new fuse. You just go to the breaker box, find the switch that's out of line, and flick it back. Easy. Okay, we've covered the epic journey, the wiring inside your walls, and the safety gadgets that protect you. But how does the power company actually know what to charge you for all this? It all comes down to one little unit of measurement, tracked by that box on the side of your house.
The magic word on your electric bill is the kilowatt hour or kilowatt hour. Now, this is a really key point. You're not just paying for how much power you use, but for how long you use it. So 1 kilowatt hour is the amount of energy a 1,000 watt appliance, like maybe a small space heater, would use if you left it running for 1 solid hour. That's the unit you're actually paying for.
And this little guy is what keeps track of it all. Whether you have an old school analog meter with the spinning disc or a new fancy digital one, its one and only job, 24/7, is to count up every single kilowatt hour your home uses.
So you want to figure out how much that all-night gaming session is actually costing you? You can do the math yourself. First, find the power rating in watts on your device. Then, divide that by 1,000 to get kilowatts. Now, multiply that number by how many hours you used it. That's your kilowatt hours. The last step? Just multiply that by whatever your local utility charges per kilowatt hour, and boom, that's what it cost you.
Okay, so let's wrap this all up. We've seen electricity make its incredible high-voltage trip all the way to your street. We've learned about the 3 key wires, live, neutral, and earth, that bring it safely inside. We know our homes are wired in parallel, so everything works on its own. We've got our safety guardians, the fuses and MCBs, and now we know it's all measured in those kilowatt hours on our bill. So the next time you flip a switch, maybe just take a second to think about that incredible, invisible system that you are plugging into. We have managed to tame a fundamental force of nature to build our entire modern world. It really makes you stop and wonder, what's the next great thing we're going to power up?